Nicole is going to share the story of how Spotify has embraced Google Cloud Platform and BigQuery specifically for their use cases. Please.
Thanks, Tina. I appreciate the intro. Hey, everyone. Thanks for having me here today. I'll start with a brief introduction. My name is Nicole, and I work at Spotify as a technical product manager in the Data Infrastructure Tribe, which is our name for department at Spotify. Specifically, I work with a team that works on building tools and to support BigQuery across Spotify. So we work closely with BigQuery every day. We, in DI and as a whole, build internal tools and infrastructure to support data at Spotify. So before I get into this talk, I want to just apologize briefly if I get a little bit technical. Feel free to find me after the talk, and I can explain things in a little bit more detail if you have any questions. So I thought I'd start with a very brief history of the short history of Spotify in the cloud, which actually, now that I think about it, would be a great name for a band. Gonna have to do that someday. All right, so 4 years ago, when we started the transition to the cloud, at that point, Spotify was almost completely on-premise and bare metal. We were doing, I think at our largest point, we had something like 2,500 nodes in our Hadoop cluster and over 10,000 machines in 4 data centers around the world. And what we were finding is that even at that kind of scale, one of the largest Hadoop clusters in Europe, it still really wasn't enough. We were expanding rapidly in the US, and we were really having trouble keeping up with the growth and being able to do our analytical work. And that in particular was a really big pain point for us. Running a single query on this cluster in Hive could take us hours. So after a couple years of small experiments, we finally decided to take the plunge and move to the cloud. And before I move on, I wanted to give a brief plug to my amazing colleagues Josh and Ramon, who'll be giving a talk about that migration tomorrow afternoon. So if you have any interest in hearing more about how we did that migration to the cloud, please listen into their talk. So for us, the move to BigQuery was actually a really big success. It was rapidly adopted by the Spotify analytics and data science community, and to this day, it still remains one of the most popular GCP tools we use at Spotify. For us in particular, what it really meant for us was that we were getting fast results. We were able to add capacity a lot easier, and we found that the integration with the other GCP tools was a real big help. As well, one of the biggest wins for us was really how it democratized access to data at Spotify. It was really that ease of use meant that more people could be asking more questions and getting responses faster, which meant that overall we were getting a massively shorter time to insight. Using SQL particularly as a querying language was really powerful for letting people across the company ask questions of our data in a way that they'd never been able to do before. So I thought I'd give you a quick example of how using BigQuery impacted our ability to ask questions of our data. So this is a kind of question that somebody a data scientist might want to be asking. How much time did users in Spain spend listening to Spotify in October of 2016? Before, when we were working with Hive, it would take us something like 16 minutes or so to get an answer for this one question. Now, when we moved to BigQuery, the same question only takes us about 33 seconds. So as you can see, a huge sea change in our ability to get those answers quickly. Now, if you multiply that by hundreds of questions asked by hundreds of people at Spotify daily, the kind of impact this kind of speed is going to have is really clear. And in case you guys are wondering, the answer to that question is the total hours are equivalent to nearly 10,000 years. All right, so what does it really mean, or what do we mean when we say petabyte scale? What does that really look like? Internally in Spotify, we sometimes refer to this as how big is data? And our answer for that is really, really big. So right now, Spotify has about 170 million active users listening to our catalog of over 35 million songs in 65 different markets. So as you can probably imagine, we generate a lot of data, and being able to ask the right questions in the right way becomes really important to us. And so that's what we end up using BigQuery for. So we use BigQuery to do that kind of analysis at a scale that we've never been able to do before. Right now, we have about 25% of employees at BigQuery that are using BigQuery on a regular basis, either directly or through custom tooling on top of BigQuery. We process around 400 petabytes of data monthly and store over 100 petabytes of data specifically in BigQuery. Doesn't even talk about things we're storing in other parts of the GCP product suite. And that also includes loading in around 500 terabytes of new data daily into BigQuery. And what that means is that in total, we end up running around 6 million queries a month. So that's a really big scale. So for us, that move to BigQuery has actually solved a lot of the issues that we used to have in our old clusters. But as we've grown, we really had to develop new techniques to ensure that we're going to continue to be successful. For us, we actually see this as a big win. We've moved beyond those lower level problems of can we even get the answers we need, to the higher level questions of how do we continue to ensure good performance if our data doubles in size again. So I thought I'd start with a few things here that we've discovered over the past year that have helped us scale effectively in BigQuery. We found that the things we're doing fall into 4 kind of categories. The first being administration, managing how BigQuery is being used across the company. Second one is around education, learning about how to tune our BigQuery performance to get the best results. Third is integration. That's leveraging the APIs and other GCP products to get the right tool for the right time. And then finally, we have working closely with Google to improve BigQuery, so working on a partnership with them. So I'm going to dig a little bit deeper into each of those. First of all, when we talk about the kinds of things we were doing in administration to be successful, one of the first things we did was move to a fixed capacity model. This has been really helpful to us because it ensures that we have dedicated slots and helps us be predictable with our costs. And that's been a big win for us. It does mean we need to think a little bit ahead to enable to grow our capacity, but we've been finding that it's actually significantly still better than the problems we were having in our on-premise Hadoop clusters for growing capacity. We still have a significantly faster speed of growth there. The second thing we do is we've been creating sub-reservations, which are kind of smaller pools within our larger reservation that allows us to isolate jobs and business-critical projects. And that's actually been really helpful for us, particularly because we regularly rebalance which projects have access to which pools. And that means that we're getting the best performance for the right time. A good example of this is whenever we're going to do a large backfill on our data, something went wrong, or we need to add some data into a table that already exists, we will move that particular project into its own sub-reservation with an isolated set of resources that it can use. And that means it's preventing that from impacting the day-to-day work of everybody else, but also ensuring that that particular job has the resources it needs to complete on time. That's been really powerful for us. We also make sure that business-critical projects are in their own sub-reservation. That means no matter what happens, they're always going to have access to the resources they need to complete those business-critical tasks. The next thing we've been working on has to do with education, specifically learning how to tune our performance as being one of the main things. For us, what that really means is learning how do we need to manage our concurrency, how do we use batch versus interactive mode to help figure out when jobs should run. These kinds of things help us ensure that we're getting the best performance when we're running things on BigQuery. The second thing we've been learning a lot about is the impact of Dremel architecture, understanding that it's not a relational database and that using a columnar data store actually provides significant benefits for certain kind of queries, but can be very different and not work as well for other kinds of queries. And so ensuring that people who are running queries on BigQuery across the company really understand how to optimize for the kind of architecture they're running on. And finally, the thing we do within Spotify is we have a very passionate community of BigQuery users, and we leverage that a lot to help share best practices around the company. Next, we work on integration. Specifically, we use BigQuery API wrappers to allow us to build our own set of custom tools on top of BigQuery to meet our own needs. This really allows us to do deeper integration with our own tools and environment while still leveraging that power of BigQuery behind the scenes. I find that that's been really helpful for us to continue growing and fine-tuning something for our specific needs. We also leverage the integrations with other Google Cloud data products, and specifically the ability to move data between different products easily. That allows us to really optimize about using the right tool for the job. Finally, we focus on building a good partnership, specifically with the Google BigQuery team, as well with our strategic cloud engineers that work with us here at Spotify. We work with them really to help keep expanding the features and capabilities of BigQuery that you really need to be able to operate at this kind of scale. What that means for us on a day-to-day basis is that we're talking with them about feature requests. As we're pushing the limits of what BigQuery does right now, we work closely in telling them, hey, these are the new features we need. This is where we'd like to see this grow. A great example of this for us is not too long ago, we were working on becoming ready for GDPR, the General Data Protection Regulation that rolled out in Europe a few months ago. And we realized that the technique we were using for encryption and decryption just wasn't going to scale to the extent we needed for GDPR compliance. So we worked closely with the BigQuery team to work on new tools and features that allow us to do that at the scale we needed to, and at the speed we needed to do as well. That's been really helpful. And then finally, we've been working closely with the support team at Google to help us with troubleshooting. Specifically, whenever we run into any issues or users have challenges, we have performance issues, we're able to really reach out and get quick responses and solve our problems very smoothly.